Very well. Now we are going to look at the various ball bearings, the various sizes, and I'll show you how we do the experiment. You will shortly see on the screen there 7 marks which are 1 centimeter apart. They are in the liquid. 1, 2, 3, 4, 5, 6, 7. So here is the liquid, and the ball bearings are dropped from above. When it reaches this line, I will start my timer. And when it crosses 1, 2, 3, 4, when it crosses this line, I will stop my timer. And each mark is about 1 centimeter apart, so this is a journey of about 4 centimeters. And we will measure the time that it takes to go from here to here. And the terminal velocity is given. It's clearly regime 1, so you see the terminal velocity right there. Now the time that it will take is of course this distance, let me call it h, that the ball bearings travel, divided by the terminal velocity. And that is proportional, since you're in regime 1, by 1 over r squared. And now I will give you not the radii, but I'll give you the diameters of these ball bearings. That's the way they come. So we're going to get a list here of the diameters of the ball bearings, and their diameters is in inches. My smallest one has a diameter of 1/8 of an inch. Then I have 5/32. I have 3/16. All these things come in inches. That's one of those things. And I have 1/4 inch diameter. If I plot here, if I give you here the diameter in terms of 1/32 of an inch, then this is 4, 5, 6, and 8. Easy numbers. Clearly, if the time that it takes is proportional to 1 over r squared, it will also be proportional to 1 over d squared. Of course, that's the same. What I'm going to plot is not 1 over d squared, but to get some nice numbers, I'm going to plot for you 100 over d squared, whereby d is then in these units 1/32 of an inch, and that gives me some nice numbers. Then I get a 6.25 here, I get a 4.00 here. You can see 100 divided by 25 is exactly 4. I get 2.78 here, and my last number is 1.56. And now I'm going to time it, and my timing uncertainty is of course dictated by my reaction time. That should be at least 0.1 second. However, you will see when I reach the 1/4 inch ball bearing that it goes so fast that my error could well be 0.2 of a second. It goes in a flash. So I would allow here 0.2 of a second, and here I really don't know, maybe 1/10, maybe 0.2 of a second. You may ask me, why didn't you give us the error in the diameter, which ultimately of course translates into the error in the mass? The reason is that these are so precise, the way you buy them, that the uncertainty is completely negligible compared to the timing error that I make. So I won't even take that into account.